Good morning. Today I will present how to apply a OpenMatch module and how to apply Colab training to train OpenMatch text model. In the OpenMatch, this is a GitHub repository that can useful for many text AI model such as text retrieval, text re-ranking. And to use the OpenMatch, usually we have to need a physical GPU for training. For example, if we don't have the GPU, we can use a online platform, online solution from Google Cloud, from Google called Google Colab. And today I will present how to use Google Colab for training repository from the OpenMatch. Before we go into the Google Colab, we have to remind that Google Colab right now is so popular around the world. Maybe you already know many information about the Google Colab. The environment in the Google Colab, that is the Jupyter Notebook. And from my personal perspective, Jupyter Notebook is quite a little bit difficult for debugging. And the OpenMatch is kind of big repository. They contain many folders, many algorithms, many functions. There were many libraries that are conflicted to the current version nowadays. So therefore, before running on the Google Cloud, before running on Google Colab, we should fix those errors on our local PCs. So the first step, let's install the OpenMatch to our local repository. In my PC, I will use PyCharm for debugging and for solving any possible errors before running on the Colab. And in here, as you can see, I have a short recorder on how can I install OpenMatch on the local. First, I will clone the OpenMatch using the GitHub to clone every information to our local PCs. So as you can see, after cloning, I have a folder named OpenMatch and all of the information already stored in this local PC. And then after I finish cloning the data, cloning the repository, I will install necessary Python libraries for running the. I will install the necessary library for running the code. To do so, let's take a look at the short video clip here on how can we install. First, we will create a new project. We don't need to name the project, and in here we will generate a new virtual environment. And this virtual environment will be used for installing the necessary Python libraries. So after setup, we will have a screenshot right here, and yes, you can see the virtual environment already shown here. And as introduced by the OpenMatch, at the guidance on OpenMatch, you will type a line called pip install e, and then every necessary library will be installed. So now they are trying to install some dependencies from the library. They are installing the necessary transformer because the OpenMatch mostly they work on the transformer in the Hugging phase, so they are using the transformer. And notice that the last update of the OpenMatch was 2 years ago. So the latest model of the transformer may not be suitable with the transformer version installed at the time OpenMatch was developed. So be careful when we're using that. And while we install some libraries, we will see the library conflict with the current Python library, with the current transformer library. We will see very soon. So after we finish the library installation, we will have a screen like this that to show all of the necessary libraries that already finished installation. And then, because for training the data, the embedded model and re-ranking model, we should have the data first. And for the case of training a retrieval model and re-ranking model, we will use one of the most popular one of the most popular data set called MS Macro. And as you can see in here, there are many guidance on how to install the MS Macro dataset, such as using wget to download the data and unzip the files. We have to notice that these codes are running on Linux, but as you can see in my PC, they are using the Windows. And technically, we might not need to execute all of these code. We can just simply go directly to the MS Macro website and download the data directly from that website. And after you download all of the necessary files, you will have a file named macro storing right here inside of the OpenMatch repository. And when you open, you can see there are a lot of data from the MS Macro, such as the list of the corpus, which is containing the entire information, the entire text data. And then you can see some queries used for training the model, some queries used for developing the model, some passages placed as the negative passages when training the retrieval, because as we know, when you're training the embedded model and re-ranking model, given a query, you should have a positive and negative passages. So in this file, they contain the negative and positive passages for you. And as I informed before you place your code on the Google Colab, you should verify on your local PC to make sure that there will be no bug happening, no code error happening, or no code logic happening. In the Google Colab, you have to pay, and sometimes you have to use the computer unit from the Google Colab. So if these errors happen while training on the Google Colab, it will kind of waste of money for you. So make sure you solve every error or every library conflict first on your PC. So as you can see right here, the OpenMatch, now they will guide you to build a training files. In this guidance, you will execute the Python script build train.py, and this step will generate negative passages for you. As I remind again, given one query, you must have positive and negative passages because we are training the retrieval model and re-ranking model. And this file, technically, they will generate a negative passage for you. And in this method, you should declare the tokenizer, which is technically that is the tokenized model that you use. And this tokenized model will be applied, and that model will be used to find positive and negative passage for you. And technically, this kind of code will split the data into a train model. This data will be used for splitting the train model and validate model. And you may ask which tokenize that you can use. As you can see it here, the tokenized name is D5 base scale, but technically this kind of tokenizer is not available right now on the Google Hugging Face. So you have to go to the Hugging Face website. You check for available tokenized model that you can use. As you can see in here, one of the tokenized model that are available on the Hugging Face is called T5 base or T5 large. So you can use these models and apply that on the tokenized model. So after you execute this code, you will have after you execute this code and you do some concatenation as shown on the guidance of the OpenMatch, you will have a new data for training and a new validation files for validator model. So after you execute on the T5 library, on the T5 folders, you will have the training files and the validation files. We will use the training files for training the model and validation file for validate the model. So now we will execute first on the PC to make sure no error happen when we execute the model. So as we can see that they just see that they cannot find libraries, the torch library. So because of that, we will verify and install the new torch library. It will take some time for running, and they will use the torch 2.5.1, the version 2.5.1, and all of the necessary Python libraries. Okay, so after finished installation, we will edit the script because as you can see, the command that run by the script. So you use the PyCharm, you copy to the script, and you execute. And thanks to this function, you can run directly on the PyCharm, and because of the script, you can also debug on the PyCharm. And as you can see, there is another error comes that we forget to have the encoding, because the code will open the files. Many JSON files that we have, the code will open the files. So, but they have some errors on the codec, so we should add the function encoding and execute the code again. So as you can see right now, the file, the buildtrain.py is successfully training. The buildtrain.py, they are successfully on running, and they can generating the training dataset. Because of the time, we have not much time, so the time for running the code is quite long. So I just show a briefly demo on how the code is executed. Okay, so right now, after we have the data, we already have the positive passages and we have the negative passages. The next step is that we will train the model. First, we will train the embedded model. And to do so, we will use the function Python OpenMatch driven train dir. We will assign the output directory, which is our T5 directory. And then the embedded model, the tokenizer model, which is the T5 base, because I used T5 base. Notice once again, the T5 space scale declared in here is not available in the Hugging face. So we have to change that. And then we pass our training files, our validation files, and some other hyperparameters for the model. And then we will start execute the code. Make sure that there will be no code happen. Okay, first again, we will declare configuration, some parameters in the PyCharm. And after finish declaration, we will start running. So as you can see here, there is another error come out. That is, we missed the transformer library. So just install the suitable transformer libraries. Okay, now it's finished. They are finished installation for the training for the transformer libraries. Now we execute the model again. So as you can see right now, the model can read hyperparameters, and the model can access to the model to the database and load the database out. And they start the training process, as you can see here. But once again, you can see there is another error comes. They say that they get an unexpected keyword argument num item in batch. Technically, that error comes from the transformer version. And thanks to the PyCharm, and we declare on the PyCharm, we can debug and see what's going on. And that error comes from the transformer version. So to fix this problem, we have to downgrade the transformer version. So before doing so, first I will uninstall the current transformer. The current transformer is 4.48.0. We will uninstall that because that version is not matched with the current OpenMatch repository. We will install the 4.45.2, and that version will solve the problem. So now we finish the installation, and let's run again. And as you can see, we're going to the training again, but there is another error come. They step in epochs. They say that division by 0. Technically, this error comes from the fact that the model cannot read the files incorrectly. So you have to go to you have to investigate on the library, check the reading progress, check the reading process, and solve the bugs. So this task is quite time consuming. So I just want to show in here to demo that when you train the model from a open source repository, there will be many things that can happen. Libraries error, the code errors, or the version is too old, long time not update. So first you have to clone that repository to your local PCs. Let's use PyCharm and solve every possible errors that can happen. Then after you get the clean code, you will push the clean repository to the GitHub. As I mentioned here, after you finish everything, you push your clean repository to GitHub, which means that in this case there will be no error happen. However, there is one thing you have to notice, that our data is quite large. It's a large size, and we cannot push directly to the GitHub. So as you can see in here, this is my GitHub, which is containing my clean code after I revise the OpenMatch code. But I cannot upload the data in here. So to solve this problem, you will download the Google Drive that are available on the Google Drive website. You download for your Windows, and you connect to the PC so that you can have a shortcut in here, and then you can upload your data set directly to the Google Drive. After you upload to the Google Drive, as you can see in here, I upload to the Google Drive. Then as the next step, we will clone back our clean code. We clone back to the Google Drive. There is two methods we can do. First, we will clone by execute the code on the Colab. But if you are not yet familiar with the Colab, or is it like too much to do, you just simply copy the data. You copy your entire repository directly to the Google Drive. So in here, I will show you the sample process of how can I do that. So we access to the Colab web page. We run on the new notebook, and then we will execute some line such as call mounting the driver, access to the drive, make a new direction called embedded ranking, and then clone the data, clone the GitHub to our Google Drive. So the entire drive will be cloned and saved directly on our Google Drive. So as you can see in here, after I already have the embedded ranking libraries, and the entire the entire GitHub repository is now available in the Google Drive. So right now we can simply copy our data to the macro and MS macro folders and place it here. So now it's time for training, because right now our code is clean. We just simply click the play button and train the models. Because we are using the GPUs, so we have to select a GPUs. And for the Google Colab Pro that I'm using right now, the price is $9 or $10. But this does not guarantee that 1 month with your Google Colab subscription, you will use whole days on the entire month. That's not gonna happen. There is one policy called the computer unit that you have to notice, that by default the Google Colab will assign you 100 computer units, but every different GPUs have the different amount of computer unit consumption. For example, you can see in here we have A100 GPUs, L4 GPUs, T4 GPUs, and other TPUs. The most powerful GPUs right now is A100, and the A100 GPU has quite really high compute unit consumption. I remember maybe around 6 or 8 computer units per hour. However, if you select the T4 GPU is quite weak compared to others. If A100 and L4, as you can see on my screen, 1 hour is just consume 1.66 compute unit. So as you can see on my screen, because I use the models quite often, so right now I already have 24.7 computer unit remain. So with 1.66 computer unit per hour, if I run it continuously, I am just only have 14.87 hours left. So which means that the time remaining is not much. So now after we select the computer unit, frankly I am recommend let's use the T4 unless you have lots of money. If not, just use the T4, and then you just simply pass the code to the Google Colab. The code will be run in the Jupyter notebook, and you just call the code, access to your current repositories, activate your virtual environment, install some necessary libraries. And one more thing is that in the code there will be have the code to load the data and collect positive and negative passage and others work that will be used the FICE platform. And because we are using the GPUs, we will install the FICE GPUs as well as the transformers, as we can see on the code when we install. Sometimes we have to install the transformer, and then we just simply pass the Python command. The command line execution will pass directly to the Google Colab, both index, retrieval, and other Python libraries. And you remember to change your output directory and other information such as the corporate path or the query path. So now it's time for execute. So now we will set up the GPU. I will use the T4 GPUs and connect. The Google Colab will create a virtual environment for me that using the T4 GPUs. So now it's connect, and let's check configuration. I have 15 gigabyte of GPU RAM, which is large enough in my opinion. And then we will connect to our local libraries, the place that we store our GitHub repository. And then we will install some necessary files, necessary libraries. So now we are installing the file. We are installing some repository. It will take some time. It's quite a little bit long. Okay, so now we will check the NVIDIA SMI. Yeah, we are running the T4 and install the FICE GPU and then start execution the build index. As you can see right here, the code will be execute the build index, and we can access directly our OpenMatch directory in here. Because the time is quite long, so I just run a few lines of code just for demonstration. Yep, now they can load the model. They can show some hyperparameters for you. And yep, they can make the index. So far, currently this step we don't use any GPUs at all. But now is a test. This step they will use the retrieval model to retrieve information to indexing the positive and negative passages. So at this step, we will use the GPU, and as you can see that we will consuming around nearly 3 gigabytes of GPUs. Yeah, the speed is a little bit fast, and technically it's taking quite a long time, so maybe I will stop right here. I will stop the code execution right here. Yeah, okay, now let's run another module, the retrieval module, to retrieve information given the query. So the first step, they will do the embedded, convert the text into embedded vector form. And now in the second code, we will use the model to retrieve the information and using the embedded vector. So right now, the GPU, once again, they're using, because the GPU right now they're running in the batch. So the memory consumption is higher than before. And the code is running successfully. Yeah, after finished training, in practice, after finished training, you can go to another execution queries. You can go to another lines of code and keep running, generating some training and evaluation. And all of the information will be saved to the MS Macro T5, and when you access to MS Macro T5, you can collect accessory files that will generate and place in there. But remember to notice to check your Google Cloud memory consumption. Okay, so that is my presentation and demonstration about using Google Colab today. In this demo, I applied the Google Colab on training embedded and re-ranking model using the OpenMatch repository. Let's remind. First, let's clone the OpenMatch repository or any other open source repository. Let's clone it first and running on your local PC. Solve any other errors that can happen. Maybe the library conflicts, maybe the code conflicts, any error conflicts. Then, after you've solved any errors and execute correctly on your PCs, then you upload the entire repository to your personal GitHub. And at that time, you can access to Google Drive. You clone your clean repository to the Google Drive, to the Google Drive, copy all of your data to Google Drive, and then you can go to Google Colab and execute the code on the Google Colab. Remember to check the suitable GPUs. The higher, the powerful of the GPUs, the more of the GPU unit that you cost when you're running. Okay, so that is my presentation today. Have a good day.